Okay, now we're going to talk a little bit more about unit vectors. And remember, a unit vector is a vector whose length is 1. From head to tail, it has a length of 1. We can find a unit vector in the direction of a particular vector. In fact, let's do this one, where v is 8, comma, negative 20. And then we're going to verify that the result does have a length of 1. So what we're going to do is kind of look and take a picture of where this is. So it goes to 8, negative 20. So I'm going to go out 8 this way and down 20. So that means that it ends right there at 8, negative 20. So here's my vector. Pretend that's straight. Okay, so let's be thinking of this vector here. And it's like that. Now certainly that vector does not have a length of 1. What we are going to try to do is take this vector that we have right here, like this, and we know it's not a length of 1. We're going to take it and back it up or scale it back. You may think back to using dilations like we did in geometry and also in the beginning of our unit circle days. We're going to take this thing, keep the direction the same, but we're going to scale it back so that it's only 1 unit long. So what we are looking for is that little black vector right there. What are the components for that? Scaling it back. And our scale factor that we're going to scale it back by is right here. This is the scale factor that will reduce our vector v back down to just a length of 1. So what we need to do is find 1 over the magnitude of v. So we need to figure out what the magnitude of v is first of all. So the magnitude of v, we're going to take our horizontal component, square it, take our vertical component, square it, and we're going to get 64 plus 400, which is 464. Now, I want to reduce that radical as much as I can, so I'm going to do this for now. I may not do it in later ones, but I'm going to take this number up here in the corner. I'm going to take 464, I'm going to break it down into its prime factors. If I divide that by 2, that would be 232. Divide that by 2, that's 116. Divide that by 2, because it's still even, and that's 58. Still even, divide by 2, and that is 29. And I'm done, because 29 is prime. So I can be thinking of the square root of 464 as the square root of 4 times 4 times 29. Well, there's the pair of 4's right there. So they get to come out. So this is 4 root 29. Okay, so this vector, this blue vector over here, has a magnitude of 4 root 29. Now the unit vector, the black one, that has the same direction but a different length, is going to be found by taking 1 over our velocity that we just found, 4 root 29, times the vector v. And the vector v is 8, negative 20. So all I need to do is kind of distribute this in. So u is going to be 8 over 4 root 29, and negative 20 over 4 root 29. And I can reduce these just a little bit. 8 over 4 is simply 2. So I have 2 over the square root of 29, my horizontal component, and then my vertical component, I've got negative 20 divided by 4, so that's negative 5 over root 29. And I believe this is how your book will end up leaving it, not rationalizing denominators or anything. If it does, you'll adapt to that. But this is okay as it is. So we have found the unit vector, but let's verify that it actually has a length of 1. That is, let's check to see what is the magnitude of u. It should be 1. So we are going to take the square root of 2 over root 29 squared plus negative 5 over the square root of 29 squared. So I square the top and the bottom when I square a fraction. So I have 4 over 29 plus, and then square the top there, negative 5 squared is 25 over 29. And adding my fractions together, I've got 29 over 29, and that is 1. So square root of 1 is 1. So yes, it is a unit vector. It has a magnitude of 1. So now let's take a look at some standard unit vectors and a different way of looking at these guys. Sometimes we don't write them in a component form. We write them in this IJ form. It's called a linear combination. So I represents the vector 1, 0. So basically, notice that this is the x only. So I is the horizontal component. It will only change things left and right, whereas j only has the y. It has 0 for its x component, so it doesn't go anywhere left or right. So this basically only takes care of vertical motion. Okay, so your horizontal component of v is your v1. Sometimes you'll see it written as a. Your vertical component, v2, sometimes you will see that written as b. The linear combination of them is sometimes written as vi, b sub 1 I, plus v sub 2 j. Or, likewise, if you might see it with the a's and the b's, it might be written as ai plus bj. The a and the b are simply describing how far, and the I and the j mean, they'll tell you whether you're going horizontally or vertically. So there's that linear combination. Okay, now we're going to take a vector and write it in terms of a linear combination. So let u be the vector with the initial point -6, +2, and terminal point 4, 3. Then write u as a linear combination of the standard unit vectors I and j. So if you need to draw these out, go ahead, but you can also do just the head to tail method. So u is going to be, got our components, I'll put it in component form first. We're going to take 4 minus -6, so head minus tail, so 4 minus -6, and then we'll take 3 minus 2. So that is, it is 10, comma 1. And that is our component form. Now, if I put it in a linear combination form, this is kind of my A, or my V sub 1. This is my B, or my V sub 2. So this component form of 10, 1 is the equivalent to saying 10I plus 1j. I'm not going to write the 1 because we hardly ever write the 1 as a coefficient. So there's 10I plus j. That's the linear combination form of the vector. Okay, now let's use this in vector operations. So if we have u and w, and we're supposed to find the new vector v by taking u minus 2w. So if V is U minus 2W, I write these out, U is 2I minus J, and then I have to subtract 2 times W, and W is I plus 2J. So that part is represented there in green. So now I'm simply going to distribute and do what I normally do with like terms. So I have 2I minus J minus 2I minus 4J. Well, my 2I minus 2I, those are canceling, going away. And then I've got my minus j and my minus 4j, so in the end I'm going to have negative 5j. So you'll notice this does not have any horizontal components, just vertical. So we can write it just like that as negative 5j. If you were going to write it in a component form, it would be 0, negative 5. All right, so again, this is the component form. And this is the linear combination form. And I will be telling you what form we'd like them in, and probably would accept either one.